Kia ora, everyone. Let's get started on the second lesson for this week 5 lockdown. So like I said earlier, there are only 2 lessons for this week 5, so I'm noting this is the second one, 2 out of 2. You're basically done with the videos at the end of this. But do keep in mind, even though you're done with the videos, or sorry, even though I've only done 2 lessons in what normally is a 4-lesson week, the reason why I have done that is so that way you guys have some time to do the follow-up work, and also be mindful I put a CPR quiz. So do keep in mind that's why I don't have you overloaded with lessons, because I'm mindful you guys need some time to digest what I've been talking about. Anyway, our fun yak today is exploring the reasons behind melting and boiling point of different substances. It's going to be the final lesson for this chunk of thermochemistry. So just kind of wrapping up that Lewis structure, shape, polarity, and forces question that you're going to get. So we'll basically be 2/3 of the way through the material by the end of this week. Oops, too fast. All right. So, on our checklist today, we are still working on number 5, which is the melting and boiling points and the solubility information. You're more likely to get a question on melting and boiling points, though. We did start talking about this in the previous lesson, because you guys were looking at the different types of forces, but I want to do just a little bit more tidy up so you can answer the melting and boiling points in a bit more detail. Like I said, that's probably going to be the question you're going to get. All right, so let's talk about state changes. When we are talking about state changes, you might also hear them being referred to as phase changes, and that's just basically a recognizable state that a substance is at and how it changes. So, for example, we're talking solids, liquids, and gases. This is stuff you guys did in year 9 science. Kind of funny that you're revisiting it now. Allotropes are basically just the same element, they're just in different physical states. It all has to do with the bonding that's present, which, in this case, the bonds that we're talking about with the covalent molecular is the intermolecular forces that are basically breaking. Now let's look at some of the terminology that you'll see for thermochemistry. The first one is the latent heat of fusion. Fusion just means that you're going from a solid to a liquid. It's just a fancy way of saying melting. I do want to start pointing out this terminology that you're going to be seeing, because we'll look at it in our next section of thermochemistry. You guys have seen this before, which is the delta H, which we know is the enthalpy, and it's just stating the energy for that reaction. What's going to be new for this year is there are going to be some annotations on the bottom that's going to tell you about what type of reaction it is and what the energy is going to be used for. So if you see fuse, it just means fusion, and that's basically the energy required to break the weakest forces between my particles, going from a solid then to a liquid. The next one that you then have is the latent heat of sublimation. Again, you're going to see sub then. It makes kind of sense of what you're going to be looking for. And this is just the energy required to break, again, the forces between particles. In this case, we are going from a solid to a gas. So we're bypassing liquid altogether and we're just jumping straight to gas. Very common thing when we're talking about things with really low melting and boiling points, such as dry ice. It goes straight to the gas when you have it at room temperature. The last one that you're going to need to know then is the latent heat of vaporization, which is vape. In this case, we are going from a liquid to a gas. Really important that you know this stuff, because they like to ask a really basic question where they ask you to write the equation for state changes, and they'll tell you they'll just basically say, latent heat a vaporization of this, like water, or they'll just write delta vape H, and they want you to do that equation for it. So all you have to do is do H2O brackets liquid, arrow, H2O brackets again, gas. So it's a really easy kind of basic achieve point. So just know your terminology, and like I said, we'll see it again when we do the thermochemistry calculations. This is a really common diagram that you'll see. It's basically kind of showing you visually what's happening with the phase changes. So basically you have a solid, and you're going to have in the case of covalent molecular, lots of intermolecular bonds. When we start to melt them, we're starting to break those intermolecular forces and then going into a liquid. There's still some attraction between them. And then once we add more energy, you're going to really kind of sever those intermolecular forces, and these molecules will be able to move around freely. What I need to point out to you guys are these kind of flat sections. So what you're basically seeing is an increase in the temperature of the solid to the melting point, and then it's going to stay at the melting point for a while, and then once it's all melted, it becomes a liquid, and then you'll see an increase in the liquid, and then again, it'll stabilize at the boiling point, and then you'll see the increase again in temperature, but in this case, it's going to be the gas state. You guys have actually seen this before in year 9, and one of the common questions you might get on the assessment is, why is it holding at this temperature, or why is it holding at this temperature for a while? And it's just because instead of the energy being used to increase the temperature, so when we increase the temperature, the particles are moving faster, they're vibrating faster, and that's going to increase what we measure then as temperature. But you hit a point where the temperature doesn't change, and that's because instead of that energy being used to kind of vibrate the molecules and read the temperature reading as a higher number, that energy is going to be put into breaking those intermolecular forces, so that way it can change state. And then once it's changed state, it's going to be able to then start heating up again, because again, those particles can now use that energy to move faster, until you hit the next point where then it needs to break the intermolecular bonds and form the gas. So that's what we're referring to when we see melting point and boiling point. I think that's basically all I wanted to say about that. Yeah, so here's just a nice little summary table. Basically, again, very common things you're going to see on the assessment, and what I've selected as a CPR quiz question this week has this kind of table. Basically, they'll give you a substance, and what they'll probably give you is either the enthalpy for like fusion, vaporization, sublimation, so you can compare and contrast how much energy is required, or they'll give you a melting point or a boiling point and you compare and contrast. What they often then leave blank for you to fill on the table is the type of forces that break the particle apart, because they want to obviously see if you know what's holding that type of solid together. And you'll be basically comparing and contrasting things to be like, why does this have a higher boiling point than this one, or why does this require more energy than this one? They will probably focus on the molecules, but they can stick in the other types of solids if they want, as a nice little kind of refresher. It's still fair game from last year. So here we see sodium chloride, we see copper, and we see silicon. Just keep in mind the stuff that you learned last year and what bonds are present to make up that type of solid. But most likely they'll ask the molecules, because the categorization of these weak intermolecular bonds are what's new for this year. So that's just information on what the table looks like. You'll probably get something similar with different substances. This will be blanked out, and then they'll give you some information about melting, boiling point, or enthalpy. I've just included this as well because it's just a nice way to kind of see it in a different way. Just a reminder of the different types of solids that we've talked about. And then, like I said, just comparing and contrasting melting and boiling point. In this case, they've included electrical conductivity, but unlikely they'll ask you that sort of question on the assessment. Like I said, they're going to be focusing on this sort of stuff. So yeah, that's basically it. Nice, kind of short and sweet lesson. Yesterday was, not yesterday, the last lesson was kind of the meteor one. This one is just kind of being more specific, because they often ask about melting and boiling point. So summarize what you guys learned today, or learned in this lesson. You're exploring the reasons behind the melting and boiling point of different substances. Be really mindful of those horizontal sections in those graphs, because you might have to just explain, why are they horizontal temporarily. Following up from this lesson, go to lesson number 12, which is phase changes. Lots of recommended follow-up there. You don't have to do all of it. Just pick what is relevant and how much practice you need to understand the material. Make sure you put your answers or evidence of your work into that Google Doc. The other thing that you can complete now that you finish this lesson, I would suggest do some study first, is that CPR quiz on intermolecular forces and phase changes, the answers are on my Google site. And like I said, both of those documents are on Google Classroom, and they have been assigned as an assignment, so you each get your own copy to write in. That's basically the work for today. So hopefully you have done basically one video lesson, first video lesson, first video lesson and some work, second video lesson and some work, probably another day for just some work, and then the final kind of lesson is your CPR quiz. All right, that's it for week number 5.